Hi everyone. In this video, I'm going to talk about insertion in a red-black tree. In this particular video, I'm going to give you an overview or a high-level understanding of how to insert a node in a red-black tree. And in the next video, we are going to talk about the specific algorithm and the different cases that you have to follow to insert a node in a red-black tree. So in front of you, we have an example of a red-black tree. Now, a red-black tree has four properties. The first property is that every node can either be red or black. Now, the root as well as all the leaves, which are the nil nodes, are all black in color. Now, and the third property is that a parent of a red node is always black. The final and the most important property which is listed on this slide is that all simple paths from a node X to all the decadent leaves have the same number of black nodes, which is called the black height. I just went through these four properties really quickly because we just covered them in the previous video in this playlist. So now let's look at insertion in a red-black tree. Now when you insert a node in a red-black tree, these operations itself can cause certain modifications. So when you're inserting a node, you're adding another node into this tree, and that can cause the tree to become unbalanced. Now, when you're inserting a node, you have to decide what color of the node that you're going to insert, and that can violate some of the properties of the red-black tree. So what we have to do is we have to restore the structure of the red-black tree via rotations. So rotation is the main property that we are going to use to make sure that the red-black tree remains balanced and all the properties of the red-black tree hold true. So let's try to understand this idea of rotation. Now let's look at this figure. So here on your left, you have a figure where B is at the root of the subtree, and then it has a left child, which is A, which has two subtrees, alpha and beta, and on its right, it has the subtree, which is gamma. So what is going to happen is, let's try to right rotate B. Now when you right rotate B, what is going to happen is B is going to move down like this. A is going to move up to take B's position, and beta is basically going to now become a child of B. So this is what is happening. So you see, as B moves down, I'm going to highlight here, A moves up, and this child, the beta, is now attached to B. That is what happens when you right rotate B on this particular figure here. So let's erase all this so that we can look at left rotation. So in left rotation, what we are going to do is we are going to consider this tree here, and we are going to left rotate A. So when you left rotate A is going to come down here, B is going to move up, and beta is now going to become the right child of A. That is, the subtree is now going to be attached to the right side of A. So that is what is going to happen when you apply these rotations. So you can either rotate right or rotate left. Now we will see how these rotations are going to be useful in fixing a red-black tree. As I told you, in this particular video, I'm just going to give you the idea of how we go about fixing a red-black tree. The exact algorithm we will discuss in our next video. Now, let's assume that you insert X in this tree. Now, what you want to do is, when you want to insert a node X, we would like to color the node red. Okay? Now, why do you want to color the node red? When you color the node red, the only property that can be violated is property 3. Now, if you recall what is property 3 is the parent of a red node has to be black. That is the only property that can be violated. So how are we going to fix this? The idea is you will move the violation up the tree. So you will move the violation up the tree and you will keep doing it until everything is fixed. So that is the main idea here. So let's look at it. So first, let's insert 15 into this tree. Now when you insert 15, 15 is going to be inserted right here. Now, because 15 is inserted and 15 is, the color of 15 is red because we're inserting a red node, property 3 is violated because 11 has to be black. So we have to recolor and move up the tree. So what do we do? So what we can do is we are going to color 11 as black. So let's just go back one slide. So what we see here is 15 is inserted and its parent 11 is red and the other child of 10 is also red. Now what we do is when we recolor, we are going to recolor 11 to be black, 8 to be black, and are going to make 10 as red. So this is just a way of doing it. So it's an ad hoc way. It's not an algorithmic approach yet, but I just want to tell you how we are moving the violation up in the tree. Now, the reason why we colored both 8 and 11 black is that we want to make sure that the black height remains the same. Now, what we are going to do is the parent of 10, which is 18, is at this present moment red, and you cannot have that. So one way to fix that is to right rotate 18. So 18 is going to come down here and 10 will move up here. So this is how it will look like. Now this tree is becoming very lopsided. So what is going to happen is we are now going to left rotate 7. So if we left rotate 7, 7 will come down there and 10 will move up. And what is going to happen is this tree will look somewhat like this. Now what we did is we did some recoloring and we recolored 10 to black. So adopting this entire process, we have actually rebalanced the red-black tree. Now, of course, what you might be thinking is, how am I supposed to implement this? For that, what we are going to do in the next lecture is, I'm going to give you the pseudocode for implementing this. But the main takeaway message from this video is, how do you actually apply rotations and recoloring to a red-black tree? That is the main takeaway message here, that we can do a bunch of recoloring and rotations and balance a red-black tree. Okay. With this, I'll actually conclude this video, and in the next video, we'll look at the exact algorithm to balance a red-black tree. Thank you for watching.